In this series of brief videos, we'll touch on the basics of hypothesis testing as well as some of the steps that we need to go through in a practical sense to actually conduct a hypothesis test. What is it that we're really doing and what does it all mean? We're, just for a frame of reference, in a block of material that's part of our work on statistical inference. And the work we'll talk about here is based on the idea of a sampling distribution that we developed in our last block and used to develop confidence intervals to test, to estimate the value of a population parameter. Our learning objectives are the following. We want to explain the null and alternate hypothesis statements and build these from some verbal statements. So we'll see some examples of claims that we'd like to test and the appropriate null and alternate hypothesis statements. We'll talk about the types of errors that we can make when we conduct this type of testing. And there are two types, called a type 1 or a type 2 error. Then we'll go ahead and carry out the hypothesis test on a population mean and a population proportion and interpret these. Along the way, we'll understand this idea of a p-value for a hypothesis test. Again, what is it? What do we do with it? And how does it lead us towards our conclusion in this statistical test? And then lastly, we also will look at hypothesis tests for another class of test, which is a difference of means on samples. And we'll look at both paired and independent samples. So what is a hypothesis test? It's based around a hypothesis. And a hypothesis is a statement concerning the value of some population parameter. It's a claim. Just as in a research scenario, one would make a hypothesis. That's the claim that the study is intended to investigate, either to show that the claim is true or the claim is not. So this hypothesis is this statement, and the hypothesis test determines whether or not the statistical data, typically from a single sample, supports the hypothesis or the statement or claim that's being made. And I give three examples here, and we'll look at each one of these a little later on. But could we conclude that more than 14% of customers will buy some new product? Can we conclude that some new equipment or machinery or technique or process is going to reduce our cycle time, presumably below some established value? And thirdly, could we conclude that a typical worker is working something other than 40 hours based on a sample from the previous week? So in these three examples, we see a larger than some number or some proportion of customers buying the new product, cycle time being reduced from some prior or established value, and in the third case, the hours worked in the last week as being not equal to, being something different from, again, some established value. Three different examples. What we're going to do is consider a sampling distribution. And we talked about sampling distributions before. This is for a given sample statistics such as the proportion or the mean. It's the distribution of all the possible sample means, for example, that we could take from a population where the sample size is the same. So it's the distribution of all the sample statistics from all the possible samples for samples of the same size taken from a given population. So if we're talking about a sampling distribution of sample means, it's the distribution of all the sample means from every possible sample that we could take of the same size from a given population. Similarly, we could have a sampling distribution of sample proportions where we take our population, we take every possible sample we could take of a given sample size, and the distribution that we're talking about here would be the distribution of all the sample proportions from all the possible samples of the same size from that given population. So that's what we're going to use as our basis. And the idea here is, you'll notice in the examples I gave, we were always making a claim or investigating a claim about something being changed from some known value, some reference value. We call that our null value. And we're going to consider a sampling distribution around a population that has that null value of as the population parameter in question. And then we'll take our individual sample and we're going to measure the sample statistic from our sample. So if we're interested in doing a test on a mean, and we want to say, for example, that this new process is going to reduce our cycle time from a value of 12 minutes, let's say, that we've had in the past. Well, we take our sample and we measure the sample mean. And what we would consider is a sampling distribution of all the possible samples that we could take of the same size for a population that's based around this null value. We're going to assume a population mean of 12 minutes, the null value from our test. And then we measure the sample statistic from our given sample and say, based on this sample mean, what's the likelihood that this sample comes from this null population, this population that's centered around our null value of 12 minutes in the example that I'm considering? Or is it more likely that the sample comes from another population? And we will ask and answer this question based on what we know about the distribution. Again, if we think of a bell-shaped curve and our empirical rules, we know that 68% approximately of the distribution is going to fall within plus or minus 1 standard deviation from the mean. And similar numbers for 95%, 99.7% of the distribution. We're going to use those kinds of ideas and apply it to this sampling distribution and say, hey, there's only a 95% chance that a sample, one random sample from this population centered at the null, would have values within plus or minus 2 standard errors. So if I have a sample that comes from very, very far away, many standard errors away from the null, then the probability of it coming from this population that's centered at the null is very, very small, based on what we know about the shape of the distribution and how far it extends in terms of numbers of standard deviations or standard errors away from that null value. And this is really the essence of the test. We're going to use what we know about the typical spread of this sampling distribution and use that to determine how likely it is that the sample I have comes from this population. And that's where we're going to go. So there are 5 steps, and I'll conclude this introduction by talking about the 5 steps that we would use. So once we understand the claim that's being made, we want to clearly state the null hypothesis statement and the alternate hypothesis statement, and we'll go over those in a short while. We want to understand how sensitive a test we need to make, and we do that by determining something we call the significance level of the test. We might be given one in a particular problem, or we may assume one, as we'll see. Thirdly, based on the population parameter that we're interested in testing, we're going to determine the test statistic to be used. Meaning, when I ask the question, how many standard errors is this sample statistic away from the null value, I'm going to respond to that by saying it's this number of standard errors away. And the question is, will I capture that as a z-value, as a t-value? It depends on the shape of the distribution. So it'll depend on what parameter I'm testing, because as we've seen, we're going to take slightly different shapes of the distribution for the sampling distribution for a mean versus the sampling distribution for a proportion. And those are only 2 examples of all the possible sampling distributions that exist out there, and they each have a shape, and some of them are not at all like the z distribution or the t distribution. Our 4th step is to go ahead and conduct this test, to take a look at our sample, compare it to the sampling distribution based around the null population, and say, hey, does it look like this sample has a good chance of coming from this null population? If so, I'd have to say that there isn't enough evidence to support my claim that something different is happening, that it's that my cycle time is significantly reduced from 12 minutes. If it looks like, hey, this sample is very unlikely to come from a population centered at 12 minutes, and it seems to come from something significantly less, then that'll be the decision I make. Our decision always is whether or not we're going to reject this null hypothesis, which says that no, things look like they're just as they've always been, or that they're not significantly far away from the null or reference value. That's our statistical decision. And then, of course, we're always going to tie this back to the related business decision. What does this say about the advertising claim I want to make, or about the operations claim that I want to make, or the financial claim that I want to make? So that wraps up our brief introduction, and we'll come back and take a look at hypothesis statements in particular.